Welcome, everybody. We are me and my Dennis. We are talking today about ELSA, a regulatory reporting platform for the on-premise cloud. Let that sink in for a moment. That's a mouthful, right? Promise next time we're going to pick a different title, but much shorter than this. But what are we doing here? We are presenting a platform for regulatory reporting because currently what Bafin is doing, it works, it's fine, but we can definitely see improvement. And this is something for other regulators that might be interested in doing something like that, rethinking about how the regulatory data is being processed. And so we hopefully can be a little bit of an inspiration of what can be done and how could it be done. Well, my name is Björn. As you know, what I already said, I'm the head of XBRL unit at Bafin, and together with Dennis, the founder and CEO of Reportix, we're working on this project together at Bafin. Today, we're going to be talking about, well, I'm going to give you a brief introduction about what Bafin is, what we do, and what ELSA is. Then we're going to look at the current state of data processing at Bafin and compare it to how it's supposed to be in the future. ELSA is still a work in progress. Then I'm going to hand over to Dennis, who is going to give you the technical details of ELSA. And I'm going to conclude this little session with the outlook and the benefits that we're expecting to see. So first things first, an introduction. Bafin is the German financial regulator. We supervise about 2,500 financial institutions and more than 500 insurance and pensions companies. And just by those numbers, you can figure we do receive quite a significant amount of filings per year, primarily in the following formats: XBRL, XML, CSV, JSON. We receive it. The reason why I'm showing you this, it's, of course, all the regulators will probably know this is not a perfect world. We don't have a single data format that we can focus on. We can't just simply say, I'm just going to pay attention to XBRL. We do have to cover them all, and that makes it a little bit more difficult, and that's what we're trying to solve with ELSA. ELSA stands for Electronic Submission and Analytics, and it's designed to be a platform for regulatory processing. So a little bit more about that in a moment. First of all, I'd like to show you how we're currently doing it at Bafin with regarding to data processing. So the status quo looks a bit like this. We do have a portal where all data gets received, and ideally a data warehouse. We do have a data warehouse, but ideally all the data should end up in there. And for example, we receive XML filings. They get passed through an XML processor and end up in the data warehouse. Fair and square, easy, simple. Our first mandate that came along was Solvency II a couple of years ago. For that, we also receive it, of course, at the portal. It gets passed through an XBRL validator. We built our own XBRL parser that wrote the data into the staging database, and then from there it gets passed on to the data warehouse. The next XBRL mandate that came along was CRD4. And as you can see, there's already a difference right here. We skipped the parser in this one. And what I'm trying to get at is that all these things are historically grown. We have individual processes per mandate, basically, and that is not something that can really scale. And what really broke the camel's back was SDMX came along, a mandate with SDMX, and we did not have a processor that would fit into this environment here and really didn't know how to solve this. We basically had to start from scratch again, and that is something that really should not happen. So to sum it all up, data processing at Bafin currently looks a bit like that. It's not pretty. It works, yeah, sure. But could it be better? Definitely. Each of these little squiggly lines is basically one mandate. And the reason for that is it's a historically grown process. Whenever the need arose, we had to find the means to get the data across from A to B. And another thing is that each mandate is handled as its own project. So that means each time a new team is taking on the task of bringing the data from the portal to the data warehouse, which of course results in individual implementations. Another issue we're having is scalability. We're receiving more and more data with each mandate that comes along. And by doing that, by having these individual processes that cover the data and bringing them from one place to the other, we can't really scale, at least not automatically. So that makes it a lot more difficult. And another side effect that we're having with this is data silos. By having these individual processes bringing the data across, everybody figures out a way of how to get the data wherever they need it stored. That does not mean it necessarily all ends up in the data warehouse where analytics can be performed upon, So these are the three major issues we're having with this. Like I said, it's not perfect. It's working, but we definitely do see some room for improvement. And that's where ELSA comes in. That is how ELSA is supposed to look. Isn't it beautiful? Isn't it so much prettier? No squiggly lines. We've got straight lines. We've got the void between the portal and the data warehouse. It's filled. But basically where there was Wild West before, ELSA takes care and makes everything better. Wow, that sounds good, right? Well, the idea is basically, like I said, we're filling the void between those two entities, the portal and the data warehouse, and we're creating a platform that is able to host any kind of processor that we need to have for any kind of mandate that comes along. So I have an example here: XBRL, XML, CSV, any kind of processor. We might not even know about this data type yet. ELSA is, at least from the architectural point of view, supposed to be able to handle this. Now, we didn't just simply wake up one moment like, hey, let's do ELSA. This is a great idea. No, we actually had quite a thought process about this. We sat down and did some brainstorming about what would be the most important quality goals for a regulatory processing environment that we would like to have, like ideal system, basically. And we came up with about 20 to 30 of those quality goals. Here are the top 5 that we whittled it down to, because we ranked them, of course. So as I mentioned before, scalability is a huge item for us, because we're receiving with each mandate, and we usually do receive about 1 to 2 mandates per year, we receive much, much more data. And so we need to be able to scale, even in an ad hoc basis, like a larger mandate comes along or something like that. In addition to this, new mandates need to be much easier and faster integrated into the existing system than they currently are. It shouldn't be that every time we start from scratch and get the data from the portal and bring it to the data warehouse. There should be some ways that we can reuse. So, and also, of course, handle new data types, as we had to do with SDMX. And at the same time, we would like to prevent data silos by standardizing data storing in the data warehouse. I think it goes without say that we, would like to have a high performance system, and it should be reliable. But the dependencies on third parties, I'd like to point out, that's noteworthy, because what we're actually trying to aim at, the current system is very, very tightly coupled with our portal and our data warehouse. Like I said, historically grown system. And if any change would be made to the portal or the data warehouse, it would have a significant impact on data processing. And that should not really be the case. So in order to reduce these dependencies, we would like to have, a much less tightly coupled system, much more loosely coupled. And that is the point where ELSA is also coming in. Well, at this point, I'm going to hand over to Dennis, who's going to walk you through the rest of the technical application.
Thank you, Björn, for this starting this. These quality goals are very important, because we now have to make some technical decisions how to actually implement ELSA. And I cannot stress enough that to have these prioritized goals is very important, because then we can verify each decision that we are going to make against these goals, if we can actually achieve them. So how can we achieve these quality goals for data processing on a technical level? And now you will see at the bottom always these 5 things, because they are so important to verify each decision against those. I have put them, the 4 ones, always on the bottom, and I will verify whether our decision holds against those quality goals. And the decisions we have to take is basically on the infrastructure side: which infrastructure do we want to use, and the system architecture, which we want to implement. So the first one we are looking at is the infrastructure part. Now let's look at a classic infrastructure setup. So here you would usually have just several servers which you would run. On each of these servers there would be a different application, for example, a database, an application server, web front end. This is the classic 3-tier architecture. And on each of these servers, you have dedicated hardware, you have an operating system, and the application layer. Now, does this scale for ELSA? No, it doesn't scale at all. It also, I'm not giving you all the details why it doesn't scale, but it's obvious. If you want to, make it bigger, you have to add a new server. This is really a hassle. And also adding new mandates would mean to set up new physical servers. the performance is bad because it also doesn't scale and it's not reliable at all. If any of those servers will stop working, then the whole system would go down. So this is not scalable at all. So how could this be improved? Now let's look at the next step of evolution, and that is actually already cloud. And here we are looking at cloud of virtual machines. That's the usual setup that also AWS uses, Google Cloud, IBM Cloud, and so on. Azure, you name it. So they all use this kind of cloud infrastructure. So what you actually have is basically some hardware at the bottom. This could be just a bunch of RAM, disk space, and CPU. On top of that, there would be something running which is called a hypervisor. This is to virtualize hardware. It can assign virtualized hardware then to virtual machines, and these virtual machines itself contain virtual hardware, an operating system, and an application layer. So now all of this looks very much like the server already, and it basically is. It's only that the virtual machine is virtualized and can be more easily scaled. That's also why we make this yellow. So this is already quite good, but it's not yet there because the virtual machine is actually like a server. So if you want to really dynamically scale something, it's like if you press a button of a server. Now you all know how this works. You have to wait a long time until this server actually comes up because the whole operating system needs to boot, then the application layer needs to boot, and so on. So it's not really dynamic. It's not really fast. It's not what we are looking for. And scalability is the top priority goal for Bafin. So it really needs to be scaling quickly. Because if you think of when you collect the reports, they are all coming at the same time. You know this problem. It's all the peak processing that you have to do. At the last point, when it's possible, they all report at once, and you have to process all of this. So this needs to be able to scale very quickly. Now, how could this then be improved? So what is the next possible evolution step? And that would be maybe looking at containers. Now you would of course ask, what is a container? Now a container would usually run on a huge server as well. You would have hardware, RAM, disk space, and CPU as well. But now you have an operating system running on this server. This could be, for example, Linux. And then on top of that, you need something which is a container engine. And you all maybe have heard about Docker. This is one example of a container engine. On top of this container engine, you can then spawn many containers. And the difference here is that each container just contains the application layer, nothing else. So this is really as lightweight as it can get. And this can spawn up even in milliseconds. So we can scale this very, very easily to even hundreds of containers. Now, is it now solved? Not just yet. We still have it yellow because with the Docker container engine, you have to do a lot of manual work yourself. So all the management and so on is very difficult to do to actually really make it scale. And that's why it's only yellow. It's not there yet from our perspective. And the next step of evolution is then coming into play, which is Kubernetes. And Kubernetes in the cloud even. By the way, Bafin is using an on-premise cloud because when you speak about cloud, it's often AWS and so on. But you can also host it on-premise. That's what Bafin decided to do. It gives you more control over the security, over the hardware that you're using and so on. That's why Bafin decided to do that. And on top of cloud, you can actually also run something which is called Kubernetes. And Kubernetes is a container management platform. So here's an example. Let's say you have a data center 1 with several servers. This can be virtual machines or servers, you name it, it doesn't matter. Then you have another data center 2 for reliability. That's very good. And then on top of that, you would run Kubernetes. And Kubernetes would hide all this complexity already. So you would just have one Kubernetes that you talk to. You wouldn't know what kind of clusters is underneath. And on Kubernetes, you can then deploy lots of these small little containers, which can be very easily scaled. And even if you add more, they only contain the application layer. And if you even add more physical servers, you wouldn't even notice on the application level. So the container management would completely hide this complexity. So this really solves the problem of scalability. It's really fast to scale even single components up and down. This is what we are actually using for ELSA. And now we have looked at the infrastructure. Now let's have a quick look also at the system architecture level. So here, this is just a reminder because Björn already had a very good slide to show this. This is one example of how a mandate would be actually implemented. Basically, each of these components make total sense, but what is important is maybe we should look at which parts need actually to be implemented by the project team responsible for this mandate. And let's highlight this. It's all parts. So they are completely responsible for the whole application and all of the components that are actually used. And if there comes a new project, the new team is also responsible for that. So it's basically redundant work. Very obvious. So this does not scale at all. Has a lot of dependencies and so on. Now, what we are actually implementing is something which is called a pipes and filter architecture. This is when you have a data source and the target system, then in between this, you would like to have pipelines. And this pipeline would just pipe a standardized message from filter to filter. And this filter is nothing else but a software component. And this is completely asynchronous, which means it's non-blocking for any component. And that also means you can identify single components, which are slow, and then scale those single components individually. This makes it really scalable also. This goes from one to the next filter. Each filter applies some sort of application to the data and then gives it to the next one until it's in the target system. Now let's go back to our first project. How would it look like for this project as an example? Now you see, that looks quite similar. It's not so much different, but in this case, we have done everything very cleanly. It can be individually scaled. And now let's highlight the part which the actual project has to implement. Aha, now it's only 2 components. So we have gained something. This is a real cost reduction, right? So the platform has standard components which can be reused in every project. And the project itself has only to take care of 2 components in this case, which is the pre and the post validation. So we have gained something already. And this is very good for our target goals. Now, there's something in addition what ELSA provides, and this I'm just mentioning because it's too much detail otherwise. We have some transaction management, we have journaling, we have technical monitoring, we have tracing, we have alerting, and auto-scaling operators. So all of these are very important. And if every project would be responsible for these to implement, they would each forget something. So this would never work. So what you gain with ELSA as a platform is 2 things. You have a reduction of work. You only need to implement less components, and you get a lot of features for free because all of these are handled by the platform, and each project doesn't have to actually think about this. They get this for free. So this is the 2 main also cost reductions that you have. So this is very good for our goals. Now, another concept that we are using is statelessness. Why are we enforcing statelessness and what does it mean? Now let's take an example. If we get a submission and then let's say in the first component, we do some processing of this data and we store some of the data in some of the target systems. Then we pass it on to the next filter and now an error happens. So it fails. Now, what do we have to do? Actually, we have now an inconsistent state. This is very dangerous, very bad. So what we would have to do is we would have to implement on the transaction level, basically, a rollback mechanism, which is very hard to do. And if a custom component is implemented by the project, then they have to take care to implement this rollback mechanism, which is really bad. And so we decided, no, we enforce no filter must have any persistent side effects. And this helps us a lot because we can pull the plug at any time. We just replug it in, we start the system again, and it starts working. We have to think about nothing, no rollback, no nothing. It just works. And this is, of course, also very good for new mandates and reliability. Now, one last thing to mention on the system architecture part is the standardized output. So what we can do as ELSA platform on a more global level is we can enforce, and this is to avoid data silos, basically. We can enforce every pipeline when we have several pipelines for projects to actually submit the same standardized data into the target database. Of course, this does only work for groups or categories of data like XBRL, XML, and so on. We cannot enforce it globally, but for XBRL, it works. We can enforce them to store the same data in the data warehouse. And this avoids data silos, and the departments themselves, they can still access the data as they wish to. So they don't have to use all of the data, they can just pick their part. So this is for the downstream processing of the projects. This is also very good for the new mandates, and it removes the dependencies and it avoids data silos. Thank you. So now I would hand over to Björn for the benefits.
All right. Thank you, Dennis. Yeah, I just would like to stress this part real quick. I mean, processing data is great. I mean, having it in the database is, of course, key. But what is much more important is analytics afterwards. It's, the users really need to be able to analyze the data, and having it in a standard format in the data warehouse where it is easier to then analyze based on having a standard model is going to speed up analytics, hopefully, a lot more than we currently are able to do. All right. Benefits and outlook. Yeah, well, first and foremost, this is most important to me, standardization. I think standardization, especially in software projects, is an important aspect because it provides so much more benefits for future stability, growth, and all that good stuff. So, as I mentioned before, we're trying to standardize not only the processing, but also the storage of data in the data warehouse to enable analytics to be easier. We're abstracting data, the processing of data. So the mandates itself, they don't have to worry about all the heavy lifting anymore. That's been taken care of by ELSA. And last but not least, and definitely important, we make it much easier to onboard new mandates by having an infrastructure where you can just basically plug and play, put a new mandate in there, and it continues running. So going away from implementations more towards configurations. That's the goal. Of course, scalability, I think we've stressed it more than enough, is one of the major items here that we're expecting to improve. By having the on-premise cloud solution, we would be able to scale even on unsuspected loads or even just larger mandates. And another item that's very important to us is cost reduction. Having each mandate implemented by its own project is, of course, also a cost factor because you oftentimes start over again and it's not really efficient. So having a platform that it gets implemented and maintained is, I'm expecting it at least, going to be much more cost efficient in the long run rather than having to do it all over again. So those are the major benefits that we're expecting of ELSA. I mean, I'm saying expecting because it's still a work in progress. And what is our outlook? So we're going to, I mean, the outlook in general is very good. We're expecting it to be well. We're going to start, I mean, while ELSA is able to support any kind of structured data or any kind of data, so to speak, at all, we are going to start with XBRL as our first mandate. I mean, what else could I say? We're at an XBRL conference, right? But no, seriously, we're actually going to go with XBRL first. And we are expecting it to be a significant game changer for data processing at Bafin compared to the status quo, which is, has all these negative side effects that I currently mentioned. And yeah, so hopefully ELSA is going to make it all better. Thank you very much.
Okay. Thank you very much to gentlemen. And because of the limit of the time, but still I'd like to take one or two questions from the floor. Any question or comment? Okay.
Hi, I just wondered, in this one slide, we saw that in the standardized modules, you have pre-validation and post-validation and XBRL validation in between. How are you going to handle it for SDMX, for example? Because it doesn't work with XBRL validation, right?
Yeah. I think what is important to mention is that each mandate can be implemented individually. So each mandate will have its individual processing steps that need to be taken. So some might have to have pre-processing, some might have post-processing. It's, that's the individuality that can still be implemented while making use of the standardization of the other core components that will always be there. So we're not taking away the individualization of the individual mandate, but we're enabling it, facilitating it with the platform underneath it.
Thank you. One more question. Yes.
Can you tell a bit more about the balance you're looking for with the dependency on third parties? Because many third parties will probably have tools and knowledge and skills you probably want to use and use best of breed. But on the other hand, they can be inhibiting by lack of control, etc. So what's the balance you are looking for as a the market authority?
Oh. Well, I can only mention the technical balance, right? I mean, the technical limitations. Is what you're looking for? For example, let me just go real quick. The processor, our XBRL processor, for example, or any kind of processor, we'll place it into a context where it is, again, through an interface communicating with the ELSA platform. So currently it's embedded into the processing, and the new system is going to be an external component that's just going to be talked to through an interface.
Yeah.
So again, we have loose coupling while we have the core component is going to be independent of the processor. And that allows us to implement various types of processors while keeping the core components the same.
Right.
So
One more question, or?
yes.
Okay. Oh.
Thank you. It looks really interesting what you're doing. One question that I have though is, do you know that there are already a lot of frameworks for achieving this kind of moving applications to the cloud? Why did you decide to build your own framework, like for orchestration and all of that, and not rely on maybe something that it's already out there? I don't know, like Azure Functions or Durable Functions, something like that, that maybe cover more scenarios, I understand this part where you want to keep the data in-house, like a private, not fully running on the cloud. But apart from security, do you see other benefits of building your own framework for processing these kind of filings?
I mean, just as a German regulator, we are kind of forced to stick to an on-premise cloud. We're not able to go to the public cloud. So that is, even if we would like to, it's not feasible at the moment. And so that is the short answer. If that suffices already.
Excellent, thank you.
I just had a question, like whether this particular system is going to take care of integration with the source systems,
Integration of the source system.
like the consolidation tools or the financial planning. There are some implementations which require data to be fetched from the source system. Will you be considering that as well?
Sure, if I understand. I mean, our source system, the portal, is going to receive any kinds of data. And we, again, also have an interface that we interact with the portal in order to receive the data into ELSA. But ELSA is only supposed to be handled for data processing. So purely that.
Okay.